three types of problems. Obvious problems are the problems that you know how to solve. Doesn't mean they're easy. I can ask you, write me this algorithm, prove me this theorem. You say, okay, it's going to take 2 weeks. And then you come back and you did it. Non-obvious problems are the ones that might take an unspecified amount of time. You might work on them. You don't know what to do. You know you will eventually solve the problem, but you don't know how long it could take, how much effort. And then there are the problems that keep you awake at night. The problems that might not even have a solution. Maybe there is no solution. There is no ideal solution. Maybe there is a trade-off. Maybe you have to settle for something that is good enough. It might take you years. Those are the problems that you can call deep. We talk about a deep problem today, but first let's talk about refinements. How many people here are using refinements in their code? Just a few, and that is a fact. Just a few people, and they've been around for a long time. They have been an official part of the language since Ruby 2, but we have been discussing them for years before that. So before introducing refinements, let's see what is the problem that refinements want to solve. Why do we need refinements in the first place? In Ruby, you can do this. You can reopen a class and define methods in the class. If you've been coding in Ruby for just a few days, you know this. It's one of the most important features of the language. Some people, in this case, I'm reopening the string class, the library string class, and defining a new method in that string, in that class. And now every string has the method. Some people call these open classes or dynamic class scope. Most of us call it with a term that is a little bit ironic, slightly negative. We call it monkey patching. What is monkey patching good for? Why is it so important and so Rubish? You can probably think of 5 or 6 or 7 use cases for monkey patching, but I came up with 3. 3 important ones. The ones that, 2 of them are the ones that everybody is always talking about. First one that you heard about many times, textbook example, domain-specific languages. This is a piece of code from a pretty old version of our spec. And it's using monkey patching. For example, the should method, it's not supposed to be there, right? There is a method called should on numbers. So somebody monkey patched that method in, I don't know, fixed num, or maybe one of fixed num's ancestor classes like number or object. It's object, by the way. Why do we do this rather than just say assert equals? It's nicer. It's just nicer, but we care about that. We care about aesthetics in Ruby, so we prefer to do it like this. This is one case for monkey patches. Another one is convenience methods, which is a sub-case of domain-specific languages. Once again, textbook example. Active supports time management methods. Is this different than saying minutes of 20, saying 20 dot minutes? It's nicer. Once again, we care about that. Third use case, not as common, but I wanted to mention it here because actually it's more common than most of us would care to admit. Method wrappers. The idea is I want to wrap additional functionality around an existing method. For example, in this case, the method length in strings. I'm wrapping functionality around that method in place. I don't want to subclass, for example. So what I'm doing in this case, it doesn't really matter how I'm doing this. You probably know this technique. It's called sometimes an around alias. I'm aliasing the old method, and then I'm monkey patching the method and calling into the old method from the redefined method. It's a way to monkey patch functionality, and so that everybody dealing with strings now uses the new method. This is also a good example of the problem with monkey patches. If you do this, essentially your code is doomed. Your process, at least, is doomed. It's gone. It might last another few milliseconds, but then it will crash. Because everybody is relying on the old length method in strings. Everybody is expecting it to behave like that, and now I'm changing it, so your own code jams Ruby's standard library code. They are not going to work anymore, so it will crash. In other words, the problem with monkey patches is that they are global. And global things bring bad luck in coding. In general, global state is evil, so we would like to have something like monkey patches, only local. And this is what refinements want to be. How? Well, let's see how we can use refinements. Simple two-steps process. We define a refinement, and then we use it. Defining a refinement, we use a module. Modules are used for a lot of things in Ruby. They are used as mixins. They're used as namespaces. Now they are also used to contain refinements. Once I have the module, I use the refine keyword inside the module. I say which module or class I want to refine, and then I write my refinements, just like monkey patches. Now I can use this. To use it, I can have another module, for example. In this case, it's the module that is using the refinement. I gave this module a very long name so that we don't get confused between the module that defines the refinement and the module that uses the refinement. And inside this other module, I use the method using. And now the refinement is active here. I can call it. And it's only active here. This is the crucial difference between a refinement and a monkey patch. It's only active, to be precise, in the area that goes from right after the using to the end of the module. I don't necessarily need a module. I can also use a refinement right at the top level in my code, like this, outside of any module. And in this case, it will be active from right after the using to the end of the file. And finally, I can use a refinement in a string and pass that string to eval. And in this case, the refinement is active from right after the using to the end of the string. Simple. Apparently, that's all there is to know about refinements. They look just as simple as that. First, you define the refinement. Second, you use the refinement, and that's it. Except that there is another case that is actually turning out to be quite deep and complex. What happens if I do this? I told you that the refinement is active inside the class, right? Inside class C. Now I'm reopening class C. Basic Ruby feature. Will the refinement work there? Let me make it just a little bit more complicated. What if I do this? What if I inherit from C? It's kind of like the same scope, right? The subclass kind of shares the scope of the superclass. So will the refinement be active now? just a tiny little bit more complicated. One thing that we do a lot in Ruby is this. We use a method called class eval or module eval, it's actually the same method, to reopen the scope of a class. Once again, it's made for that. That's exactly class eval's job. Reopen me the scope of this class. And what happens now? I'm re-entering the scope of the class. Is the refinement active now? If you've been coding in Ruby for some time, you might say, well, yes, I expect it to work, right? This is just a scope. We are closing and opening scopes all the time. This is how scope work in Ruby. At least this is what I think about in Ruby when I think about a scope. I think about dynamic scopes. They're dynamic because you can close them, you can reopen them, you can nest them, do a lot of cool stuff with them. So they are supposed to work. There is no reason why they shouldn't. But actually there are a few reasons why this is potentially dangerous. And there has been a lot of debate before Ruby 2 about these in particular. Let's look at the problems you can have with the refinements that are dynamically scoped like that. First, some people say they can make your code very confusing. Let me show you an example. It's a bit long, but it's not complicated. I'm just defining a method add that is taking two things, probably two numbers, and it's using the method plus on one of the two things and passing the other thing. So it's probably adding the two numbers. And then I'm calling this method add 3 times. Once in the scope of some class, another time in the scope of some other class, and finally at the top level, but after using a refinement called the float point math. And this refinement is not redefining add, but it is redefining plus that add is relying upon whenever I pass it a fixed num. With dynamically scoped refinements, I can have this. In the first case, I'm just getting 2. Why? Because some class is not refining anything, so I'm just calling the original method. In the second case, some other class was apparently written by a JavaScript developer who decided to do a lot of casting and converted all the numbers to strings and then concatenated the strings, just because. So I get a different result. And in the third case here, float point math is a refining method plus to always return a float, even when it's passed to integers. It's never returning an integer. So now, because add is calling plus, add is also returning a float. So I get 3 different results in the same code. And there is nothing in between to tell me, look, you are changing something. You have something different happening now. Expect a different result. There is no visible monkey patching, nothing. And some people say this is dangerous because it's very confusing. Because now, every time I call a method, what does the method mean? Well, it depends. It depends on which refinements happen to be active inside that scope. And because I'm changing scope all the time, I might be changing meaning all the time. And not only that, they also say, because it's confusing, it's also dangerous from a security point of view. Because imagine malicious code. If I am writing something malicious, my purpose is to make you execute code without really understand what it's doing. I'm tricking you into believing the code is harmless. And it's much easier to trick you if I can change the meaning of the code like that. That's what some people say. There is no consensus, to be honest. Some other people say, well, it's just a Ruby. You know, who cares? I can already make a mess. I can already make my code unreadable. I can already make you execute code that is different from what you expect. This is only another way to do it, but it hasn't been a problem so far. Why should it be a problem with refinements? But there is debate on that. And it's very controversial. It's a very emotional debate sometimes. There is another thing with refinements that has to do with performance. Refinements impact performance in a big way. Dynamically scoped refinements can impact performance. It's a bit hard to explain why, but I can try in 1 minute to give you the gist of it. This is the point. Imagine that you have a long chain of classes. You have a class named duck, which defines a few methods, and it's inheriting from another class named bird, which is including that module named noisy, and inheriting from another, from object actually, which is including kernel, and inheriting from basic objects. You got it. I mean, a chain of ancestors. This is what we have everywhere in Ruby. And what happens when you call a method on a duck? You create a duck and you call, say, make noise. What happens is that Ruby looks into the class of the receiver, which is duck, and starts walking up the chain until it finds the method. It looks into every class until it class and module, until it finds the method. And then it executes it. And this is time consuming. It doesn't look like much, but consider that calling methods is essentially what we're doing in Ruby all the time. We do it multiple times per statement, and some of these chains can get very long. Think of Rails. A class like Active Record Base has like almost 70 ancestors. So we are doing this thing all the time, and it ends up being time consuming. Why isn't it crippling Ruby? Why isn't it making it impossibly slow? Because we cache it. We are caching it all the time. What we do is, not us, but the interpreter. The interpreter is saying, okay, whenever somebody is calling make noise on a duck, I don't have to look through the chain. I can just go straight there because that's where it is. Sometimes you have to invalidate the cache when things happen that force you to reshape this chain. For example, I'm defining a new method, I'm including a new module. But that doesn't happen that often in a program that is running for a while. So after a while, you can rely on the cache a lot. And this makes Ruby very efficient. Now imagine what happens with the refinements. Imagine that we call make noise on another duck. Is this the same make noise? It depends, maybe. Because it depends on the context. In this case, it's the same, but if there is any line of code in between, it might change the context. So it depends on which refinements are active at the call side, right here. So essentially, I can't cache anymore, and this is apparently tragic for some Ruby implementations, in particular JRuby. They were very vocal about that. So refinements are not only impacting performance for refined code, they are impacting performance for all Ruby code. And finally, there are a few confusing corner cases about refinements. I don't have the time to show all of them, just one of them here. If you try this code, which is exactly the same code that I used earlier on as an example of a refinement, and you try this code in Pry or IRB or any command line interpreter, you define the refinement and you use the refinement with using, and then it doesn't work. It just doesn't work, it looks broken. Can you guess why? Can anybody guess why? Yes. I showed you these earlier on, right? And I said, if you have a string of code and you pass it to eval, then the refinement is only active until, the end of the string. And this is what IRB does all the time. It takes a string, it evals it. So as soon as you say using, your refinement is already inactive by the end of the using, because that's the end of that string. So let's recap. Dynamically scoped refinements. What's the good part? The good part is that they are a solution to monkey patching. They are local monkey patches. As simple as that. The bad, they make your code potentially confusing, which means a security risk potentially. they do impact performance for all code, not just refined code. They make Ruby slower, in some cases much slower. And they have weird corner cases. So there has been a lot of debate about this. Is it worth it? Is it worth doing this? Is safer monkey patching worth all these problems? And the answer was no, apparently. So this is not how refinements work today. What we have is almost the same. What we have today is, well, same thing that we've seen before. You define a refinement, you use the refinement. Exactly the same as before, but if you do something like this, you reopen the scope of the class with class eval by saying class C again, then it doesn't work. What I said before, it only works after the using until the end of the class or the file or the string is literally true. It's really only there. Only the stuff that you can see in your code, that's the place where the refinement is active. There is a technical definition for the stuff that you can see in your code, and it's lexical scope. So this is lexically scoped refinement. It's only active literally there. So what happens now? Let's look at the example. That first call to add, what do you expect to see now? Yeah. It can only be 2. It can only be 2 because there is no refinement active there. You would see it. The second one, same thing. It doesn't matter what the code in some other class does. It doesn't matter. Whatever it does, whichever refinements it uses, it cannot be active here because you would see the using. And what happens here? Anybody else wants to try? Okay, if you are in IRB, okay, that's far-fetched. Yes, it's 2. It's 2 every time. In case you are wondering what is happening here, float point mass is redefining plus, and add is calling plus. But the call to plus happens there, up there, before the using. Yeah, the call to add happens here, but that doesn't matter. This is purely lexically scoped, so what matters is the call to plus, which is the refined method. It might still surprise you. Only once. It already did. It's not gonna catch you again, in case it did the first time. So it's less confusing for sure. At least you can learn how it works, and then it's consistent. So no confusion there. Now, in the very beginning, I said there are 3 main use cases that I want to talk about for monkey patching. Let's look at those use cases again. How do refinements work? Lexically scope the refinements, what we have today. How do they work for these 3 use cases? First use case. Can refinements replace monkey patching in this case? Nope. They could if you write a using at the top of every RSpec file. If you're willing to do that, then yes, you activate the refinements and you have all your monkey patchy methods like should. But if you don't do that, this cannot work, because if there is no using, there is no refinement. It's lexical, as simple as that. Here, convenience method. I'm in a class that inherits from active record base. I want to have my active support methods. Sorry, no. If you want those methods, you use the refinement. But you have to write these in each and every file for every refinement that you want to have. Apparently, the Rails maintainers, the RSpec maintainers didn't want to do this. It kind of goes against the RAI. It's not very Rubyish to repeat something everywhere, so they didn't like it, they're not doing it. They're going a whole different direction. RSpec has a new syntax now that doesn't, is still relying on monkey patches, but it's more local monkey patches that are not as dangerous. Rails is still working the same as ever, as far as I know. So this is one of the reasons why refinements are not catching on. The big libraries are not using them. There is also another use case that I talked about, and this one also works with refinements as long as you use the using. Actually, in this case, refinements work very well because there is another neat feature of refinements that if you call super from a refined method, you automatically call into the original non-refined version of the method. So it's easy to write code that adds functionality around an existing method. But in all of these cases, you have to write it using specifically. So, the best things about refinements today, about lexically scoped refinements. They do not replace monkey patches unless you're willing to use using everywhere. And they still have some weird corner case, such as not working as you probably expect in IRB. Otherwise, they do fix some cases of monkey patching if you use the using. They do not make the code more confusing in general, and they don't impact performance, they don't impact security. And there is something else. How much time do I still have, sir? Okay. Let's talk about a deep problem. Look at this code again. This code, which is often used as an example of the power of Ruby, of the Ruby style, is actually relying on a number of features that are kind of weird and very Rubyish. For example, parentheses are optional. This wouldn't look quite as neat if I had to put parentheses after it. After all, it's a method. But I can skip the parentheses. Why does Ruby allow you to skip parentheses? I actually asked the maths, because every time I ask somebody, people say, oh, you know, maths likes Perl. So I was like, were you expecting something like this to happen? And he said, no, he wasn't expecting RSpec. This code is also relying on metaprogramming features, like singleton classes. And when I ask people why does Ruby include singleton classes, they're like, yeah, you know, maths loves small talk. So I was like, were you expecting people to use singleton classes like these? No. Singleton classes were supposed to be an implementation detail. What I'm saying is that there is a lot of serendipity here. A lot of things that were not supposed to go this direction, but just felt good to Mats and the other Ruby maintainers. So they became this thing. So a lot of features, well, I guess what I'm trying to say is, this is a deep problem. You can't just sit down and design a language. You can't say, give me 6 months, I will come up with a perfect language. At some point, it's an art. You have to come up with stuff, and maybe it feels good, and then somebody else comes in and says, hey, wow, I can abuse this feature to look like this. And this is what Ruby is doing. The thing that is surprising is that it's still doing. I mean, it's like recognizing that language design is a deep problem. You can, of course, sit down and design a language, and then you end up with COBOL. But if you want a nice language, you have to evolve it and try stuff. You have to be willing to experiment. The interesting part about this is that now there is, now this part of the presentation is improvised, actually. I was thinking that there is a lot of debate. Oh, is Ruby past its prime? Is Ruby past the curve? Ruby is middle-aged now. It's not the cool kid anymore. Right? Okay, middle-aged, so it's been around for 20 years. If it's middle-aged, it stays around for another 20 years. By the time Ruby dies, I'm personally almost 70. I could never learn another language in my life. I hope this doesn't happen. I'm willing to learn many new languages, starting with Ruby 3.0 when it happens. But it's surprisingly resilient. It has a surprisingly long life, and it keeps adding feature and experimenting. This is the cool stuff about this language. This is what made it Ruby in the first place, right? People are willing to experiment with it. They're still doing it as we speak. Thank you.